Hi, welcome you all for DataSphere. Myself Mohan Kumar. I'll be explaining you about some of the qualities of RAC. RAC being a high available, scalable, high performance database configuration. Let us look into the qualities of RAC in comparison with parallel server. So we're going to compare parallel server and RAC so that we come to know the specialty of RAC, how it has grown, scaled from parallel server to RAC. First, let us look into the configurations of both the parallel server and RAC. When you consider parallel server, so we'll have a database hosted in shared storage subsystem. We'll have instances, multiple instances hosted on two different servers in our example. So users can work with the database through any of these instances. So whereas if you look into the configurations of RAC, we got a database hosted in shared storage subsystem. We got two instances hosted on two different nodes. Okay, so primarily the difference that we can see here is parallel server is clustered using OSD clusterware, operating system dependent clusterware, whereas RAC can use OSD clusterware or clustered using Oracle clusterware also. And one more component there is a difference is here we can see interconnect. So this is the configuration wise. So the difference, if we see into the similarities, both has got a database for that multiple servers, means instances hosted on two different servers, and users can connect through any instance to work with the database. So let us look into how transactions were done on parallel server and what were the limitations and how we can overcome through RAC. Now let us consider transactions done by users. We'll assume that one of the user connects through instance 1 in parallel server environment, wants to update row number 6, updating data from 20,000 to 30,000 is the example we'll take. And whenever it is done, initially the data will not be there in instance. DB cache is brought from database. So on behalf of user process, a server process will do this activity. Block is brought to block of same version is brought to memory. So block number, version. Okay, so initially it is same. Now update takes place. So whenever update takes place, the data available initially is 20,000 is updated to 30,000 now, and previous data is maintained in undo. And whenever changes happens, version of the block will change. We'll assume that here couple of changes are happening and version has changed to 14 example wise. Now if you consider RAC, so here also we'll assume that one of the user will connect to a server where instance is hosted, wants to update row number 6, update the value from 20,000 to 30,000. Same example we are taking here on behalf of user process, a server process. Initially the block will not be there in DB cache, is going to bring that block from database to instance memory, and it is going to update that value to 30,000, maintaining the previous data in undo area. So here block which was there in database was 12, version 12 is brought to memory, and block remains same and version will change for any permanent changes done to the block. So if you look into the transactions here, okay, so done by users or applications, server process is going to perform the activity in the exact same way. There is no difference in this particular point of time, difference between these two transactions. Now let us assume that one more transaction will happen. In this case, user connects through other instance, wants to update row number 8. Assume that okay, so they want to change the value from 25,000 to 40,000. Initially the block will not be there in database. It has to in instance it has to get it from database, but here database has got a version which will be older. So what will happen now? So whatever the updated data will be returned to database, will be returned back to database. From there it is been given. Okay, so server process will bring that block and it is going to use it. Here also changes will happen. Previous data is maintained in undo area, and here change will happen to the row which is requested for. So version will change for even for this also. So what is happening is whenever the block is required which was there in the other instance has to be returned back to database and it has to give to the other instance. Whereas if we take rack environment, block is being modified in one of the instance in database, the older copy is available. Now user want to update by connecting to other instance. Wants to update row number 8, changing value from 25,000 to 40,000. Okay, whenever the data has to be changed, so it has to get the block. Now what will happen? It can't get the block from database because still it is the older version. For our updates, always the latest image is given, but latest image is in the other instance. Now what will happen? This image, which is the latest image, will be transferred from the other instance or holding instance to the requested instance. So who's going to do this is internally rack will do this. Okay, rack will do this. So block will come. So and transaction which has to modify the data will modify it. Version will change here. What is happening is here it is writing back to database because force disk write is avoided. With this IO is reduced. So performance is taken care. See, this was okay in initial days because at that time the importance was given for availability than performance, because if one server is down, the other server should be there was a requirement. But of late what happened is, so the availability of server increased and unavailability because of any reasons of the server was reduced. In that case, performance started giving impact. Okay, so initially if you take, transactions were done only by the end users and there were very few users were there. So suppose if we take example of banking system, so initial days whenever banking was computerized, only employees of the bank used to use databases. At that time server down was the key thing that we used to hear. So to avoid that, they brought in parallel server type of configurations. So with parallel server, what happens? If one server is down, still the other server will be there. So availability was improvised. At that time, performance was not the criteria because by computerization, what the transaction time it used to take earlier was considerably reduced. So means it was reduced by minutes actually. In that case, a small IO was not very important performance bottleneck. So, but of late what happened is once data was exposed to the actual end users like customers in the form of ATMs, in the form of net banking, such type of production changes. So the IO matters actually. To avoid this IO, Oracle brought in cache fusion in case of rack environment. So means transferring block image from one instance to another instance through interconnect. With this, what happened? So IO was reduced, force disk write was reduced. So this is the major enhancements, okay, are a revolutionary feature with respect to rack comparing with parallel server. So we want to compare with parallel server and rack. If you take availability of parallel server, so started from 6x, was there till 8i, whereas rack was introduced in 9i, still it continues. Even 12c we got rack itself. But over a period of time, every version, lot of enhancements are there with respect to rack with its features to support both availability and performance. Now, whenever the blocks has to access, as explained previously, so here force disk write was done whenever a block is required by the other instance. Whereas in case of rack environment, cache fusion is a feature which helps the block to be transferred from the holding instance to the requested instance, done by rack instead of application doing it. With this, performance is taken care. See, in parallel server, so we should set a type of lock called as distributed lock manager locks. These locks were set based on two criteria on data files. Set based on two criteria. One is the type of data stored in data file and how that data is accessed. So means locks, DLMs were set on data files depending on type of data stored and how it is accessed, and we should do this manually. But over a period of time, what happened? So the type of data stored we were able to make out, but how it is accessed, so it started becoming complex because of exposure of data to end users. So in that case, so Oracle made it as automatic feature. So means Oracle itself will calculate the required DLMs for configurations. So for your files. Now when we consider parallel server and rack, if we had 5 applications to use with databases, in case of parallel server, what we used to do is we used to deploy 3 applications through one server, example wise, the other 2 through one more server. So why we should do this way? So this we should do manual load balancing to avoid forced disk writes. Means these 3 applications which were using one set of data or objects, we should deploy it through one instance. The other 2 applications which were using the other set of data, other set of objects, we should deploy it to other instance. With this, we should reduce the forced disk write and performance was taken care. Or we should do it in a way where applications which were using objects, okay, so and these applications are used in first and second sessions of the day were deployed through one instance. Applications which were using a different set of objects and used in session 3 and 4 of the day were deployed through other applications. Means manually we used to load balance. With this, effective space usage or resource usage was not happening, and we didn't have a facility of load balancing automatically. So when it comes to rack environment, so even if through these applications, if 300 sessions were established, so we used to go for load balancing. In this case, what used to happen, we used to deploy applications through any instance, and effectively, so number of sessions established through an instance was distributed, load was balanced. And here we were not considering the applications. We used to deploy all the applications through the entire cluster actually. So all 5 applications we used to deploy. If 300 sessions were established to work concurrently, so and they were balanced, load was balanced. So there are many features to take care of this load balancing. With this, what happened? Effective resource utilization happened in parallel server, rack, in considering with parallel. So when it comes to load balancing, we should do it manually, both application deployment wise and session established to the server. But whereas load balancing was done automatically using NetAid or NetStack facilities of Oracle networking. With this, load balancing was done means resource utilization was also proper. And one more dependency we eliminated with this. In parallel server, as we used to deploy applications on specific instances, it was our responsibility to start the servers in the same order so that the dependency was taken care. But whereas when we went for load balancing, all applications were deployed through the entire cluster, sessions were distributed to the available servers. So there was no dependency as such to start a specific instance. We were able to start any instance at any point of time. So with this, we were able to utilize the resources efficiently in rack. It was not efficient when it comes to parallel server. Okay, so when it comes to parallel server, it was introduced to take care of availability than performance actually. Gradually the usage increased, and so users started thinking about the performance. So Oracle brought in rack to take care of all the hindrances which were there with parallel server by introducing facilities, features such as cache fusion, load balancing with rack. So these are some of the comparisons aspects of parallel server and rack. Thank you for watching this presentation. In case if you want to get other technical details about rack and other technologies, please subscribe to our channel. Thank you.